Hey everybody, this is Larry. This is day 15 of the October LeetCode Daily Challenge. You're halfway there. Yay, give yourself a applause. Yeah, hit the like button, hit the subscribe button. Join me on Discord. I thought I clicked on it, but apparently I didn't. Let me know what you think about today's problem. So I usually, solve these ones earlier, but as you know, with the new problem release time, which is 8 p.m. Eastern time, there are days where I will have a life or at least try to attempt to have one and not be home at 8 p.m. So it's gonna come out maybe more erratically. Hope that's okay. But the spirit is here. We're still gonna do problems together for as long as we can, and it'll be good. Yeah. Okay, let's look at today's problem. Best time to buy and sell stock with cooldown. So you're giving away prizes, red prizes. Okay. There are like a number of these on LeetCode, of course. So let's kind of see which one this is. Find the maximum you can achieve. You can complete with as many with the following restrictions. If you sell the stock, you cannot buy the stock on the next day. Cooldown of 1 day. Okay. So I know that there are definitely people who jump ahead in how to write. So okay, let me step back for a second. One, I'm usually solving these live, so if it's a little bit slow, just fast forward. Look, you have the technology. I believe in you. You could do whatever you like, and you could even go back and listen to it a few times if it helps. And two is that this is dynamic programming. This is memorization, whichever one you like. There are a couple of things that some people do jump to, and I do have a video that I think is pretty okay with respect to talking about space optimized dynamic programming and the progression of getting from memorization to bottoms up with space optimization. I think it's okay. I'll put it on the link below, and it's more prevalent for this one. But the way that I think about this problem is, I may even have a good video on it. I don't even remember because there's so many variations of these buy and sell stock. But the thing that I try to do is try to be brute force in a very deliberate way, pretty much, right? So okay. So let's say we don't have a stock, right? What happens? Well, if we don't have a stock, then we can buy it on day X, right? So then let's just go can buy maybe. So you can change this. I mean, I know that there is some confusion in the past with respect to what to name the state, but the state should be that, if you want to, I don't even think it's verbose, but just to be precise, right? Which is that on starting on day I can buy the stock. Meaning, what does this mean? This means that cooldown is over and I do not own the stock, right? So these are the condition of the state, right? So here, with that said, I just call it buy, and then we have day for the day. I guess okay. Let's just call it I to be consistent with the definition. I think I is a little terrible, but anyway. Let's also change this to n is equal to length of prices. So one thing that I do jump ahead about is that in theory you can actually just maybe one way of doing it is you input the array here, and then you just take the suffix of it, right? Like meaning that okay, you can either buy on the first element or you don't buy on the first element. In either way, you do some things and then you removed some of the first few elements from the list, and then we do a recursion that way, right? So you can do it that way, and then the next thing to do is just converting it to the index, because if you look at that, if you look at the pattern of what you're doing, you're only accessing you're only accessing elements of the array, and as such, you're only accessing elements of the array, so you only need the index of the element to kind of do this for. So okay, what does this mean? Okay, if I is equal to n, then we just return 0. I can buy stock. What is the max profit? I think that's the right way of saying it. So yeah, if you're at the end of the last day, then you just return 0. You're a little bit sad because I don't know, maybe you're not sad. I don't know. And then here if there's a price on that day, you can do one of two things, which is you can buy the stock or you can not buy the stock. So let's say we have not buy. So max profit not buying. Whoops. So what happens when we don't buy? Well, if we don't buy on day I, then we can buy or we can at least consider, we could think about the decision on the next day instead. So here you can do buy of I plus 1. And then what's the max profit of selling, of buying, right? Well, the max profit of buying would be that you can sell it on the next day. So that would be my function. And then now we just return max of, so either we not buy it or we buy it. So we return the max profit of either of those two. And then now, of course, we have the sell function, which we also write a similar thing where, okay, starting on day I own the stock and thus I can sell the stock, right? So no worries about cooldown because there's no cooldown when you're selling anyway, right? And of course, like I said, I own the stock. What is the max profit? Well, if I is equal to n, then return the answer 0 because, yeah, it's just 0 because you had the chance to sell it, but you didn't, so now you're stuck with no money. So that's a little sad. So yeah, sad. So yeah, now we can do the same idea of, okay, now you own the stock, you have two choices. You can buy or you can, sorry, you have two choices. You can either sell today or you don't sell on today, right? Oh, I think I messed up something here, sorry. So max profit of buying is that you buy, and how much does it cost if you buy, right? So negative price of I is this is the cost of the stock, and then you add it to the maximum of the selling component, right? Sorry, I missed that part. But yeah, if you don't sell, what happens? Well, you can sell the next day, so you're fine, in theory, maybe, right? Or you can max profit sell. And the max profit of sell is that you do get you get to sell on prices of I on ith day, and then you add, okay, what about buying of I plus 2, right? That's basically the idea. The reason why it's I plus 2 is because you have to skip the next day. And of course, once you do this, you have to be careful about this going out of bounds, so we can just convert this to greater than n, or greater than and or equal to. And then just return max of either of those two, max profit selling or max profit not selling. And that's basically the idea, and you can start by buying or attempting to buy on day 0. So that's basically the idea behind this problem. N is 5,000, so it's kind of big. And if we kind of and if we want the code, maybe I think this should be okay. But however, if you want it for some bigger amount, you're gonna time out is the answer. Oops, what is going on here? Right, I think that should be enough to time out, but maybe not. I don't know. Maybe pipeline. Sometimes it's fast when I don't need it to be. But yeah, so yeah, so now that we structured it this way, and if you read code, it's very often that they actually put these things into the same function, maybe with a Boolean flag or something like that. But I like to kind of separate it out because it's clearer. At least I think it's clearer to demonstrate the different state. But you know, because now you can maybe do some refactoring of code, be like, oh, okay, so this state is just negative of this, you know, something like that, right? So you could change it with some if statements or something like that. But anyway, I'm not going to go over that. But the idea is that, okay, this is it. And then now we convert it by memorization by noticing that for every same input, we get the same output, right? So it doesn't change over time. Yeah. It doesn't change over time, so all you have to do is memorize it, right? Memorize it. So here we can start by memorizing the buy, and the thing that I always say is that, okay, oops. So I, what is the range of I, right? So this is from 0 to n, or technically n plus 1 if you want to be precise. But anyway, O of n, right? And for each one, we do about 2 operations because we assume that these functions are O of 1 because we look it up in O of 1. So that means that this is going to be O of 1 work per input. So in total, this is going to be O of n work or time, right? And also O of n space because it is O of 1 space per input. And similarly, we can do the same. So I'm just going to copy and paste for cell. I mean, hopefully that makes sense. Yeah. And then here we just have to, because of this, we can do the memorization. So yeah, so let's just say can, let's just say by cash is equal to, it doesn't really matter, just say none maybe, times n plus, I don't know, 2 or 3, it doesn't matter. I'm making it a little bit big, but maybe you can be more precise if you do the math. But yeah, has by cash, right? And then the idea that I'm doing here is that I'm trying to demonstrate exactly how much space we need. And this is more clear once you write it out, instead of using, say, LRU cache or something like that, because now you know exactly what you need. Well, it is, I think this could be only go to n plus 1, so that I think this is the bound. And then here, and it doesn't really matter, you can actually just do it here, right? Like put it after the if statement. But yeah, if it has by cache of I, return by cache of I, and at the very end, after all our operations, we jumped down by accident. We set the by cache is equal to this thing, and has by cache of I is equal to true. So then now we can just return by cache of I. Yeah, if we want the code, I think it still should time out, or maybe it's fast enough, I don't know, but why did I print out all the nuns? Did I print somewhere by accident? Oh, I have an array of array for some reason. That's just me being silly, and it's not 4C enough, so return the true value. Okay, so yeah, so this looks good, and it's already actually much faster, but we still should do the cell side. And cell side, we have the same idea. So I'm going to just even maybe copy and paste a little bit to save myself some time. Yeah, but that's really all I have. Let me know what you think. Let me know if you have any questions. This one has a different bound technically because it cannot go over 2. But yeah, so then here we have if has cell. Yeah. Okay. So now we can run the code, and if you really want, you can even return a bigger answer. Oh wait. A bigger input rather. I don't know what this n is, but for 5,000, it's gonna be big, right? Let's just do a lot, right? And you can still see that it should be good because, like we said, this is linear, and 5,000 linear is not that much of a big deal. Of course, if it does time out, then I will have issues to look at. Anyway, let's give it a submit. Oh, I have done it about a year ago. But yeah, apparently it's slower than a lot of people's, but that's fine. I don't mind because this is linear time, and that's lower bound anyway. So yeah, the completion streak is here. That's all I have for this one. Let me know what you think. Yeah, stay good, stay healthy. Hit the like button, subscribe button, and I hope you join me on Discord. And also, to good mental health. I'll see you later. Bye bye.